Alright, today we're going to work on scientific notation. There's a lot of different ways to do it. Some teachers will say if it's this, you move it right. If it's this, you move it left. The problem with that is when you take it in and out of scientific notation, it goes left and right for bigger numbers and left and right also for smaller numbers. So I found an easier way. First, let's start with what scientific notation is. Scientific notation looks something like this. And the reason why we use it is instead of writing out really large numbers that have a lot of zeros, we use times 10 to the 4 times 10 to the 5 to represent those zeros. So for instance, this number here would be 23,000. Because what we would be doing is moving it 1, 2, 3, 4 places. So instead of writing out 23,000, we write 2.3 times 10 to the 4th. That's not such a big deal on 23,000, but think of a number like this. We're going to add commas in, and that's a large number, and you don't want to keep having to write that number in. Plus, when you get into biology and chemistry and engineering, there's numbers where you have 23 zeros. So you definitely don't want to have to deal with that on a regular basis. The chances of you making a mistake typing this into a calculator, which most calculators won't even do, gets to be pretty big. Now with scientific notation, you can see it one of two ways. You can see 3.4 times 10 to the 5th, or you can see 3.4 times 10 to the negative 5th. And the difference is one of these is going to be a number bigger than 1, one of these is going to be a number smaller than 1. The way I've found best to teach this is when you look at the exponent that's positive, in this case, this top one, is going to be a number bigger than 1. An exponent that's negative, like this one, is going to be a number smaller than 1. So when you move the decimal place, if you move it the wrong way, all you have to do is look, okay, is my number bigger than 1? If it's not, you've moved it the wrong way. What this means right here is that we're going to move the decimal 5 places. It doesn't mean that we necessarily have 5 zeros. It just means that we're going to move it 5 places. So starting off with 3.4, which is the first part of it, moving it 5 places would be 1, 2, 3, 4, 5. So what we end up with is 340000. So we end up with 340,000. Now a quick check, is that a number bigger than 1? Yeah, of course it is. Well, positive exponent means it should be bigger than 1, so we know we did it the right way. Had we moved this the wrong way, 1, 2, 3, 4, 5, we would have ended up with this decimal, which is definitely not bigger than 1, so we know we went the wrong way, and that's wrong. Now down here, when we have a negative exponent, we now know that this is going to be smaller than 1. So if I move it to the right, that's going to give me a number that's big like this, so that's not the way to go. So I'm going to want to move it the other way. Give yourself a little room. 1, 2, 3, 4, 5. The decimal is now right here. So what I have is 0.12344. That's taking numbers out of scientific notation. Positive exponent, numbers bigger than 1. Negative exponent, numbers smaller than 1. Now to put something back into scientific notation, let's take 560,000. You always have to have the decimal in between with one number that's not 0 to the left of it, meaning I need to have my decimal place in between the 5 and the 6. If I put it here, it's wrong, because scientific notation says only one number to the left. If I put it here, I'm wrong, because I don't have a number that's not 0 to the left of it. This is the left over here, there'd be no number that's not 0. So my decimal is going to need to end up there. It's currently here. So what I'm doing is I'm moving it 1, 2, 3, 4, 5 places. So what I have is 5.6 times 10 to the 5th. 1, 2, 3, 4, 5, yeah, 10 to the 5th. Now if I had a smaller number, that look like this, I can still put that back into scientific notation. Keep in mind you need one number that's not 0 to the left. So I can't put the decimal here and I can't put the decimal here. If I put it here, I've got two numbers that are not 0 to the left. So the decimal needs to go in between the 1 and the 3. To get there, I moved it 1, 2, 3, 4, 5 times. So what this is going to equal is 1.34 times 10. This time it's going to be a -5 because the number is smaller than 1. That's how you take numbers in and out of scientific notation. The other thing that you can do with scientific notation is multiply and divide. So let's move up a little bit. To multiply. This is what you're going to see when you're trying to multiply. It's going to look just like a regular multiplication problem, except it's got the times 10 to the 4 and times 10 to the 2 in there. The way to think of this is, think of this x right here as your exponent. Think of the 4 as, think of the x as your base. Think of the 4 as the exponent, and think of this as your coefficient. So this problem would be similar to 2.3 x to the 4th times 1.7 x squared. If you were to multiply this out with exponents, we would multiply the coefficients and add the exponents. So it would look something like this. 2.3 times 1.7 and gives you 3.91. So this would be 3.91. Now the bases would always stay the same, which is still x, and to multiply exponents we add them. That would give us 3.91 x to the 6. Now coming back over to the scientific notation problem, it's the same thing. We're going to multiply 2.3 times 1.7, which again is 3.91, and the variable is going to stay the same, and we're going to end up with 4 plus 2 giving me 6. That's multiplying. Dividing is going to be the same principle, except you're going to be dividing the coefficients and subtracting the exponents. So let's take 6 times 10 to the 5th divided by 3 times 10 to the 2nd. We're going to divide the 6 and the 3, which is going to give us 2, same as we would with coefficients, and we're going to subtract the exponents. 5 minus 2 is going to give me times 10 to the 3rd. That's multiplying and dividing with scientific notation.